All right, so we're going to take a look at section 3.5 today, and 3.5 has two new sets of identities. These identities are double angle identities, and these are the three different double angle identities. So what you should notice is that there's actually three formulas for cosine of 2 theta, and so we'll just be using whichever one we need at the time, and that's great. We've got some options to see that. And this is where it was very similar to problem number 4 in the quiz that you took. There was one that looked an awful lot like cosine squared minus sine squared. I think it was reversed, but it was very similar. So you'll notice sine 2 theta is probably the nicest one, just because it's the cleanest one to work with. It sort of looks like the 2 comes out in front, and you've got sine and cosine now listed with those. Something that you want to remember then is there isn't sort of a factoring process for 2. I can't just take the double angle, that 2, and just sort of put it in front. Sine of 2 theta is not the same thing as 2 sine of theta. When I double the angle, it doesn't just double the trig value. Okay, so these are the different identities that show you how to handle with that. And then the other one are half-angle identities, and you might look at that and think, oh, those don't look pretty at all because I got lots of square roots. Not only that, but I have pluses and minuses. So which one is it? Is it plus or is it minus? Well, it depends, because it depends on the quadrant you're in, right? Okay, so cosine will be positive in which quadrants? The first one and the fourth one, right? And so it will depend. We'll actually have to stop and think to ourselves, okay, this is the angle I'm working with. Which quadrant am I in? Do I need the positive or do I need the negative? I don't really have 2 solutions, but it's very ambiguous because I got the plus or minus because it depends on where I am on the unit circle, okay? You'll notice, though, for also the horizontal tangent, we've got 3 different formulas for tangent. And that may not seem very friendly, and in fact, you might look at that and say, well, what the heck would I want the square root one for, because that one's worse than the other 2? Well, it just depends on the situation. If in the situation you want to square tangent value, well, yeah, I really do want the one with the square root, because then when I square a square root, I just end up with what's underneath there. So it will depend on the situation as to which one is most friendly to work with. Now, let me say from a numerical point of view, okay, not identities, we'll do identities too, but from a numerical point of view, what you're seeing happen here is you're seeing angles that are either half of what values are on your unit circle or twice what values are on your unit circle. So in particular, the half angles, let's look at this. So if you had an angle that's 15 degrees, well, that's half a 30, right? Double angles can help you work with that then. All right? Same thing if I had pi over 12. Pi over 12 is half of pi over 6. So I can use the half-angle identities to work with that. All right, so the first thing we're going to do is we are, in fact, going to find 4 different things. We did this last time, didn't we? I told you there's a 4-part problem. We got another 4-part problem going on here. And it's set up very much like the last ones that we did. We've got an angle theta, and our theta is within the regular unit circle, 0 to 2 pi. And we're supposed to find sine, the double angle for sine and for cosine, and then the half angle for sine and for cosine. And the information I'm actually given is that the tangent value is 1/2. So what did we do last class period when we were given some information and told to find a bunch of different sums and sums of sines and cosines? We did triangles, and we need that here as well. Okay? So the first thing we're going to do is we're going to draw ourselves a triangle. Okay, let me see how many slides I left myself space to work. Just 1. Okay. All right, so as I draw myself a triangle, what quadrant am I in? Not first or third.
Oh, third.
It is third, yeah. This right here tells me that I'm in quadrant 3. So I need to make sure when I draw my picture, I draw that correctly. So my picture needs to be in quadrant 3. Let me do that. Okay, so, and of course the angle is theta, so I'm right here in the middle, and the angle is always the central angle, all right? So tangent's 1/2, what does that mean? Okay, so opposite is 1 and adjacent is 2, almost. They are both negative, very good. So within the tangent value, we don't really see that, but of course when we divide a -1 by a -2, we have positive 1/2. And we need them negative, how come? Because we're in quadrant 3, actually, right? In quadrant 3, we did go negative in the x direction and negative in the y direction. So we need to make sure it's represented that way. So I'm actually missing a third side of my triangle. How do I get it? Somebody said a Pythagorean theorem. So this is side C. So I've got -1 squared. That's a squared. It didn't look like it, though. Let's try again. Plus -2 squared, and it equals C squared. So what's -1 squared? -2 squared equals C squared. So 5 equals C squared. What's 5? I mean, what's C? Square root of 5. Okay, so my third side here is actually square root of 5. So let's pause for a moment and actually identify what the sine value and the cosine value are based on this picture, okay? And as we identify them, we're going to leave the radicals in the denominator, and you'll see why very quickly, okay? Everybody with me on that? Are you okay with that? Okay, so we're not simplifying, we're not putting this in rational form. So we have sine of theta. What is the sine of theta in this triangle? -1, it's the opposite, over square root of 5, the hypotenuse. And what is my cosine value? Yeah, it's actually -2 over square root 5. All good? Okay, that's actually all the information we need, and because we already have the tangent value as well, if we should have needed that, to be able to find the sine and the cosine of each the double angle and the half angle. Okay? And if you aren't sure, take a look back here. The double angle and the half angle formulas are all hinged upon sine and cosine of the actual angle we're dealing with, right? Okay, so we'll do it in just in order. We'll do part A. All right, so part A says I'm going to find the sine of 2 theta. And the formula says that that should be 2 sine of theta, cosine of theta. And the cool thing is here, I never actually know what theta is. I don't know what theta over 2 is. I don't know what 2 theta is. I don't need to know any of them. I can work with formulas to do that. Okay? So never along this line are we ever finding out what is my angle. So I have 2. What is sine of theta? And cosine of theta? So if I multiply across the top, I've got 2 times -1 times -2, which is a grand whopping total of 4. And what happens on bottom? It becomes 5. And that's why there was no need for me to rationalize them. They're going to rationalize themselves in some of the cases as we work. Because I have square root of 5 times square root of 5. They're both down there. So the sine of this double angle is actually 4/5. Okay, so far so good? We're going to try and squeeze in the cosine one on the screen. We'll see if I've got the space. It's going to be tight. Cosine of 2 theta. Well, I can use any one of the formulas that I was given. I've got 3 formulas for double angles for cosine 2 theta. I've got cosine squared minus sine squared, 2 cosine squared minus 1, or 1 minus 2 sine squared. Which one do you want to use? Okay. Michael says he wants to use the first one. If you want to use a different one, go for it, and we'll make sure that we all get the same solution. But I'm going to do cosine squared minus sine squared. Okay, so we know what cosine is. It's -2 over square root 5, and I'm supposed to square it. We know what sine is. It's -1 over square root of 5, and I'm supposed to square it. I don't know what it's doing. All right, so what is -2 squared over 5 squared? All right, so this becomes 4/5. How about the second one?
1/5.
That's 1/5. And what is 4/5 minus 1/5? 3/5. Oh, look at that. I'm just going to barely squeak in my whole value there. They aren't very good looking 5s, but they're 5s nonetheless. Okay, so this is double angles. All right, we found 2 different double angle trig functions, or trig values, sine and cosine. Okay, you ready to take a look at half angles? Because those half angle formulas are a little bit less friendly. At least that's what they look like, right? All right, so the first thing that we have to decide, and we mentioned this in passing back in the first part of when we were looking at the half angles, is that our angle itself, theta, it matters where it is. So right now I know that my angle theta is between pi and 3 pi over 2. Agreed? Okay. But what I'm wanting to know on part A of this, or part C it is, of this next problem to find sine of theta over 2, is I actually want to know where theta over 2 is. So if you take a look at this expression right here, how could I find out where theta over 2 is? Yeah, so everybody was saying it, and then you changed your mind for me, Cole. You were right the first time. Divide, right? We want to divide everything that is the restriction by 2. Because if I divide everything by 2, then I have an angle theta over 2 in the middle. Agreed? All right, so we have pi over 2 to start with, and it's less than or equal to. And then I actually have what? What is 3 pi over 2 divided by 2? 3 pi over 4. Now, this isn't exactly a quadrant per se, but it lies within a quadrant. If my angle is between pi halves and 3 pi fourths, what quadrant am I in? This is quadrant 2. So, in quadrant 2, is the sign value positive or negative? Positive. It is positive. Okay? Sign is y, right? The height, when we're talking about that. All right, and then this is the square root of 1 plus cosine of theta over 2. All right, let's keep going. We'll go down on this one. A sign minus. Did I write it wrong? I did. Thank you. Let's fix that. And it's all over 2. I also didn't get that written very well. Okay. All right, so what is cosine of theta in my problem? So it's minus a negative 2 over square root 5 all over 2. Well, part of that's easy to handle. I've got minus a negative, which means plus. Yeah, so this becomes a positive. That's sort of a nice feature to handle. And then if I keep going down here, I'm going to have to get a common denominator, aren't I?
You just multiply it. Since it's all radical, can you just multiply it by 2?
Well, you mean the 2 underneath there? You can multiply by that 1 over 2. I was actually going to go common denominator on top first. You could do it the other way, though, like what you're suggesting. So I'm going to deal with just the top first, and I'm going to rewrite this 1 right here as square root 5 over square root 5. Okay? So I actually have square root of 5 plus 2. That's a 5. It's just the square root that's over the 5 only. And then it says over square root of 5. And then Lauren brought up a good fact that this is actually all over 2, which I'm going to deal with in a moment. All right, so division by 2 is the same as multiplication by 1/2. So instead of writing this here, I'm going to multiply it by, all right, come on, all right, multiply this by 1/2. So it's going to give me 2 square roots of 5 in the denominator. So this is actually now the square root of square root 5 plus 2 over 2 square root 5. And we're going to do one more step, okay? We're going to get rid of the fact that it has a square root of 5 within a square root on the denominator. So we've done this before. How do we get rid of that square root of 5 on bottom? Multiply by itself, right? So I'm going to multiply by square root 5 on top and on bottom. Looks like a 2. Let's try that again. So on top, I've got square root of 5 times square root of 5, which is 5. Then I have 2 times square root of 5. And what do I have on bottom? 10. I have 10. And all of this is under a radical. And it looks ugly.
Isn't that improper still?
Yeah, it's definitely still improper. We could deal with the fact that the square root of 10's in the denominator and rationalize that, but we're not going to be able to rationalize out the fact that we've got a square root under a square root. So your book is going to be fine. And it does, if you look in the back, leave things in this form. You know, it's not so pretty, but it's what we've got. Okay? All right, we're going to see if I have enough space over here to do part D. So part D is very similar. It is cosine of theta over 2. What is the difference in my two formulas here? The plus or the minus. That is the only difference, isn't it? However, we also have to deal with the plus or minus at the beginning. So let's start there. Cosine, is it positive or negative in quadrant 2? It's negative. So I'm also going to have a negative on the outside here. And then I'm going to have 1 plus cosine on the inside because that's the formula. So aside from the negative on the outside, what's going to be different about my answer? I mean, I already did all the work. Do I really have to do it twice? You have a negative on the outside, and what's it going to be on the underneath here? 5 minus 2 square roots of 5 over 10. That is the only thing different about this formula, is the sign on the outside and the sign between my terms. Everything else has the same numbers in the same places, and I will do all the same steps. But I've already done them once, right? I don't really need to do them twice. That's silly, right? You don't want to do them twice, do you? Extra practice maybe, but yeah, probably not. So we're done at that point. This would be my second solution. Well, my fourth one, I guess, technically, because I have 4 parts. All right. I think we have time for one more, and we'll get to the identities next time. All right, here is an angle, 15 over 8 pi, that is not in the unit circle. How do you know right now, from the get-go, this is not in the unit circle? There's an 8 on bottom, isn't there? What are the unit circle values that are in denominators that you know? 3, 2, 6, 4, 1. Yeah, like whole values. Yeah, 8 doesn't work. But what if I doubled it? What if I doubled this angle? I'd get a 4 on bottom, not a 16. I'd get a 4 on bottom. Right? If I took 15 pi over 8, okay, that's not what I want. And I multiply it by 2, I get 15 pi over 4, don't I? Now, that's not one of the 4 that you know. It's bigger than 2 pi, but it's definitely something over 4, which means I can do some adding and subtracting whatever I need with 2 pi's to get it back where it needs to go. So actually, before I do that, that's what I'm going to do. So 15 pi over 8 is bigger than 2 pi, isn't it? Well, it will be when I do this, right? So, all right, let me go with what I've got here. We're in a half angle. So this is actually half of an angle, I know, right? 15 pi over 8 is half of an angle. And so it is a half angle identity, which is the cosine one, because I'm dealing with secant, so it's cosine. Let's figure out cosine, and then for secant, what will I be able to do? Nobody knows. That's great. Awesome. How are secant and cosecant? Secant and cosine, 1 over. It's reciprocals, right? All right, so let's find cosine of 15 pi over 8. Okay, so this is half of an angle that I've got. Hence the half angle part of the directions up here, right? So cosine of 15, oh, I don't know why I have a 2 there. I'm sorry, because we're using the word half, I guess. 15 pi over 8. Okay, so 15 pi over 8, I need to decide at 15 pi over 8 which quadrant am I in. So somebody take your calculator for me real quick and take 15 and divide by 8. Tell me what number you get. 1.87. 1.87 pi. Which quadrant is that in? It's in quadrant 4. Because it's nearly 2 pi, but not quite, right? Nearly 2 pi. I'm down here in quadrant 4. So down here in my 4 quadrants, in quadrant 4, cosine is this positive or negative? Positive. Positive. So this is positive square root. I can dance to the music. 1 plus. And then what I do on the inside, I'll get this set up, is cosine of double the angle. That's what I did over here. This is twice of the angle that I originally had. So this right here is 15 pi over 4. And this is all divided by 2. Now, when we were doing the 15 pi over 4 over here, I made the comment, but that's no good because that's, well, I mean, it's not no good, but it's problematic at least because it's bigger than 2 pi, right? So how did you do that back in section 2, chapter 2? We subtract 2 pi, but 2 pi is the same as 8 pi over 4, right? So this is like having 8 pi over 4. So if I have 15 pi over 4 and I take away 8 pi over 4, what do I get? 7 pi over 4. So over here, this is positive. I won't write it anymore. But it's the square root of 1 plus, and then 7 pi, I'm sorry, it's not 7 pi, cosine of 7 pi over 4, all over 2. What is 7 pi over, cosine of 7 pi over 4? Radical 2 over 2, and it's positive because this is still actually, 7 pi over 4 is also in quadrant 4, correct? So this is the square root of 1 plus square root 2 over 2, all over 2. I promise we're nearly done. We'll do it the way that Lauren suggested on the last problem, since I said, hang on, let me do it my way first. We're going to do it Lauren's way. So I'm going to divide each of these by 2. So this is the square root of 1/2 plus square root 2 over what? 4. I divide something that's halves and fourths now. Common denominator, right? Okay, so if I do a common denominator, they're going to have both have a denominator of 4. So this will be the same thing as having 2 over 4. So this is the square root of 2 plus the square root of 2 over 4. And then on this one, Alex, I can actually distribute the square root to each the numerator and denominator, and the denominator actually will be rational. Because what's the square root of 4? 2. So it doesn't look awesome on top, but the bottom looks pretty good. So this is square root of 2, plus underneath there is still another square root of 2. And it's all over the square root of 4, which is 2. That doesn't look like a 2, but I'm not sure if I can get it 2. I can almost move it there. Pretend. There's my 2. It's supposed to be in the denominator. But I still can't get rid of the fact that there's a square root inside of a square root. I'm stuck with that part. Okay? Real quick. Did I actually find what I was supposed to find? Not quite. I was asked to find secant. So we'll pick back up with how we fix this now to find secant next class. Okay? What's that? I divided. 1 divided by 2 is 1/2. Uh-huh. And then I divided the square root of 2 over 2 by 2, which is square root of 2 over 4. Yeah. All right, so we'll pick back up and finish this next time.